In the last 2 days, we have covered a range of topics relating to iron ore, steel, scrap, ferroalloys, and stainless steel. Today, we have come up with another insightful session that will be focused on the sponge iron, that is the DRI market. I'm Lalita, editorial analyst, Steelmint, and your host for this session. With me is my co-host, Mr. Prateek Srivastav, General Manager, Steel Operations. Hi, Prateek.
Hi, Lalita.
I want to thank the Indian Steel Association for extending support to Engage 4.2. Today's topic of discussion is optimizing performance, maximizing productivity with DRI in induction furnaces. The topic itself makes it very clear what this webinar will be about. The session will focus on increasing the productivity and efficiency of an induction furnace through the usage of DRI. We'll also learn more about the future of DRI. To talk on this topic, we have with us Mr. Vivek Agrawal, Chief Operating Officer, Godavari Power and Ispat Limited. Mr. Agrawal has a wealth of experience with a total of 30 years in the industry. During his time at JSPL, he commissioned both a 350 ton per day and a 500 ton per day DRI plant. Additionally, he successfully commissioned a DRI plant for Monnet Ispat Limited in 1993. Welcome, Mr. Agrawal.
Thank you very much. Thank you, Lalita, and good morning, everyone. My brief introduction had already done by Miss Lalita. So now I will directly come to today's topic, which is about efficiency improvement in induction furnace.
Sure.
Right.
Before starting the session, a humble request to the audience. Please drop the questions in the comment section with your name and the company name, and we'll take the same during the question and answer session. Now, to set the context for this session, I invite my co-host Prateek to give a brief presentation on the Indian DRI market overview. Over to you, Prateek.
Thank you, Lalita. I'm just starting with the brief market overview, then Mr. Agrawal will take over. I hope I am audible to everyone.
Yes, you are audible.
And my screen is visible?
Not yet.
Lalita, now it is visible?
No, sir, your presentation is not visible.
Just a moment.
Yes, your presentation is visible now.
Thank you, Lalita. So to set the context, I will just give a brief overview of the DRI market. So the total Indian sponge iron capacity is around 62.25 million tons, which is the world's largest DRI producer. And in India, Odisha is the major producer, followed by Chhattisgarh for sponge iron. And this is the graph of the Indian sponge iron production. So you can see that the Indian sponge iron production has increased by 12% in FY23 as compared to FY22. And the total sponge iron production in FY23 has been 43.1 million ton as compared to 38.6 million ton in FY22. And it constitutes to around 30% of the total crude steel production in India. Steel production in India. Then we will move forward with the exports of sponge iron. So in India, the country-wise exports is dominated by Nepal, followed by Bangladesh and Bhutan. And in FY23, India has crossed 1 million ton of sponge iron export. So the total export is around 1.13 million ton in FY23 from India. This is the India sponge iron price movement for ex-Raipur and DAP Durgapur. So the price has taken a dip from January till May. So it is in at the 5-month low in this particular period. Now the presentation of Mr. Agrawal will focus on maximizing productivity with DRI in induction furnace. So how DRI maximizes productivity in induction furnace? So these are few points which will be further detailed, elaborated by Mr. Agrawal. One is improved melting rate. The another one is higher thermal efficiency and reduced tap to tap time, reduced refractory wear, and enhanced quality of molten iron. So this with this, I would like Mr. Agrawal to take it from here, and I will invite him to start the session with his presentation. Mr. Agrawal, over to you.
Thank you, Pratik. Am I audible?
Yes, sir, you're audible.
Okay, thank you very much. Thank you, Pratik, for making my work easier by giving brief introduction about me and about this sponge iron industry. So now I'll directly coming to today's this topic, which is maximizing productivity with DRI in induction furnace. Before just start this particular presentation, whether this presentation is visible or not?
Sir, shall I share it from here?
No. Just a minute. I'll just share from here only. Just a minute. So, is it visible now?
Not yet, sir.
Not yet. Okay, why it is not visible? Anyway, I'll just. Now also not visible?
No, sir.
So if you want, I can share it from here. The slide will be visible to
okay.
you.
You can just start from there, no problem.
Surely, sir.
Don't know why it is not.
Yeah, the presentation is visible.
Okay, so just before I just start my presentation, the important point is that, as we know, our Prime Minister is talking about becoming net zero by 2070, and at the same time, as per National Steel Policy, a target of 500 million ton had been put to achieve by 2050. So now there is double challenge. One is to multiply our production from now existing 120 million to 500 million ton, and at the same time to become net zero in CO2 emission. So this particular topic and this webinar is very, very relevant, because we have to achieve the production target and we have to slowly reduce our CO2 emission. So as the topic speaks, maximizing productivity with DRI induction furnace, right? So next slide, please. Please change the slide. Yeah. First of all, I just brief introduce about the company so that you should be acquainted with what we are. We are a public limited company listed at NSE BSE, and it's a Raipur-based Hira Group company. We have presence in our pellet, which is almost 2.7 million ton. We make DRI through core-based DRI kiln. Billet also we make, then wire rod, SB wire, and ferroalloys. So these are the product. I am going in short because it is not that important. Next one. These are the certificate we have. We are certified with 9001, 14001, 45001, and great place to work. Right. Next one. Now coming to this particular conference topic, this maximizing productivity is very, very important in any sector, whether it is steel, whether it is pharma, whether it is iron, whatever it is. So once you maximize your productivity, your all cost goes down, whether it is thermal efficiency, as Mr. Pratik had shared in his couple of slides. Our target is to improve the melting rate, to reduce the thermal energy, to improve heat to heat time. So once we maximize productivity, all our other cost goes down, and energy plays major role in any production, whether it is thermal energy or electrical energy. So here also we will talk about how we can maximize productivity in induction furnace. Next. We all know how induction furnace works. So it's worked on the eddy current, and it's the kind of electric it uses, which helps in fast heat transfer from its metal to crucible to metal. So it's not new for the people who are using induction furnace. Next one. Need for efficient production. These are some of the very, very important point. Melting. First, I'll tell you in our Godavari Power Ispat Limited, we focus on fast melting and improving heat to heat time. That is reduction of tap to tap time. For this, number one, we use neutral ramming mass and put our own DRI, which is around 95%. And we use high Fe material so that our melting is faster and slag generation is less. As a result, our energy conservation is also lowest and our waste generation is also minimum. Now the point is, when we say reduction of CO2, so that is possible mainly by making green steel, by using scrap, making green power with the help of renewable power, that is solar power, wind power, or hydropower, and then making steel by using scrap and green power. But at the same time, if we see, making green steel is very, very challenging and very, very costly business. So before that, we have one very big weapon, that is maximizing efficiency in our existing process and reduction of energy. So once we are using high quality of DRI, we are using neutral ramming mass. So we are able to reduce our power consumption. We are able to reduce our waste generation. That is mainly slag. So this helps in induction furnace operation and improve maximizing the efficiency. Next one. Once you maximize the efficiency, definitely your cost goes down. Your turnaround times also reduces. Quality is also better, and resource utilization is also better. Next. You all know how all we are making this billet in your induction furnace. We are mainly taking DRI, which is around 95%. We are charging to furnace, and then from furnace, this liquid metal goes to caster. And next one. And then finally, casting is being done. And then from caster, billet goes to rolling mill, where we make wire rod. And then finally, wire rod goes to wire drawing mill. Next. Yeah. So if we have to maximize the productivity in furnace, couple of things we have to ensure. Number one, people are using traditionally 79 FEM material. This we have to immediately stop. We should remember that for any process, we have to use best raw material. Because if you use less Fe material, your slag generation will be high, your yield will be less, your energy consumption will be high. So for maximizing the productivity, first is proper DRI charging, and we have to ensure that there should be proper liquid pool in the induction furnace, so that once you feed the material, it should directly goes to that liquid pool, and melting should be faster. So that's the first thing. Then your batch size optimization means when you feed the DRI, it has to be optimized, and it has to be continuous basis. You like scrap, you just put and then start melting. It is not that way. It has to be very slow and continuous. This helps in reduction of your tap to tap time, more number of heat you can take because you already have that liquid pool. Your power consumption also goes down, and your finally productivity goes up. Normally, people use silica ramming mass. We recommend that we should use neutral ramming mass. These are very, very important inputs because once you use neutral ramming mass, though the cost of neutral ramming mass is very, very high as compared to silica, it is almost 20 times. But if we compare the overall benefit of using neutral ramming mass, then it is beneficial because we have very limited availability of scrap and the cost is also matters. So we have more DRI available. If we maximize DRI of high grade, then neutral ramming mass plays very important role in improving your melting and maximizing the DRI consumption. Next. These are the couple of process parameter: temperature control, power control, process automation, process monitoring, maintenance practices, and steering mechanism. Now, these are very common thing in any process. You have to take care of your operation, because even if your raw material is best, your machinery is good, your power availability is good, but if your process is not under control, like disliking is not good, your unnecessary wastage of energy is there, people are not doing tapping on time, there is lack of monitoring, lack of operation control, that definitely, even if you use good raw material, your efficiency will not be that good. So we have to take care that your recipe, your control, your monitoring has to be equally important. Next. Now, if you see in our case, as we are showing that we have eight number of existing furnaces, 12 ton 3, 15 ton 3, and 30 ton 2. They are inductothermate, and then casters are there. Today, we are using 95% DRI in our furnaces. Hardly we are using any scrap. It's a maximum 5%. That too internally generated. So dependability on scrap is not there, number one. Number two, uniformity of input material is there. Number three, we are able to consume 100% of our DRI. Hardly there is any DRI available for the market. Number four, we make high grade pellet. As a result, we make high grade sponge iron. Our pellet quality is around 66 Fe. Gang is hardly 3% in pellet. When it comes to DRI, FEM metallic iron is 85%. Gang is only 4%. FOS is also very less. It is around 0.025. So it is not requiring any ladle refining furnace. As a result, we are able to successfully operate our furnace with only 12 to 13% slag generation and around 820, 830 gross power consumption. And yield is as high as 87%. So what I wish to say that in any process, it's not only induction furnace. Even if people are using DRI kiln or electric arc furnace or whatever process you are using, we have to ensure that first thing, we have to ensure that it has to be good raw material. Because once we do not feed good raw material, lot of energy goes waste in melting slag, in losing energy in slag generation, and energy is very, very costly. Almost 40%, 30 to 40% cost goes to energy, whether it is in DRI kiln or your this induction furnace. Induction furnace also, if you are using 1,800 to 1,000 unit, so it costs around 7 rupees. Around 7,000 rupees, 6,500, 7,000 rupees the cost of the energy. So which is alone around 15% only in electric energy. So I'll request that for any process, first thing we have to ensure that we should not put garbage, because there was a time when people were giving focus that I have to use low quality DRI or pellet or iron ore because the cost is low. But if you calculate that what you are losing by using low quality input raw material, the amount of that loss is very, very high. So at GPIL, we have done this and we are successfully achieving. So I will request to all induction furnace users that you have to maximize your quality of input material, and mainly that is DRI. So this is what we are doing and how it can be maximized as per the today's this session. That's all from my side. Next, if anything is there. So this is a brief presentation what we have done actually in our plant, what we have achieved. Data are there. If anybody wish to see, they can come and visit our plant. We have been able to reduce from slag from almost 23, 24% to 12%. That's all. Thank you very much.
Thank you, sir.
Yeah, sir, please, can you stop sharing the screen? Yeah. So thank you so much, sir, for sharing your views on the latest technologies and automation used in increasing DRI output. With this, we are quickly jumping into the question and answer session. So my first question to you, Mr. Agrawal, how are scrap imports going to impact the DRI market in the future?
Yeah, ma'am, you see, if we see the type of kind of target which we are having in front of us, that is 500 million ton. So I do not think that there is any challenge to scrap or any challenge to DRI, because we need metallics to achieve this almost 4 times target. So scrap is not going to face any problem. And same is the thing with DRI. These are all metallics which need to make steel. So we are in need of scrap, we are in need of pig iron, we are in need of DRI. So all will get the good opportunity in the market. And as such, I don't think there is any challenge to any metallics.
All right. So my next question, what is the charge mix of imported and domestic coal used by DRI manufacturers, and how effective is domestic coal compared to imported coal?
Yeah, this is very, very important thing. Just now, if you see in my presentation, I've shared that we have to always focus the best quality of input raw material. Now, as a producer, as a user, I will always recommend to use imported coal in our process. But there are plants who are using domestic coal. But naturally, because if you use domestic coal, the quality of the coal is not as good as high, which is there in imported coal. So definitely you are putting more ash in your system, in your process. Once you put more ash in your process, it also needs certain heat to heat that ash. So necessarily you are losing that heat in heating the ash. That's number one. Number two, once you use domestic coal, definitely the production volume goes down with the domestic coal, and the life of the plant also reduces, because with domestic coal, due to high ash, the tendency of formation of accretion is high. So once we use domestic coal, your process gets deteriorated, your kiln gets deteriorated, and finally you have to end with the less campaign life. So I will not recommend to use domestic coal, but if people are using because of their cost benefit analysis, if they really do the impact of shutdown, the cost of the shutdown, then definitely they will feel it is always better to go for the higher quality of coal. That is definitely imported coal.
Sir, thank you. Pratik, do you have any questions?
Yeah, Lalita. Thank you, sir, for giving detailed information and answering our question. My next question will be, sir, what is the future of DRI industry in India, and what role does advanced technology and automation play in optimizing the performance of an induction furnace?
You see, I think the future of DRI industry is very, very bright, because number one, as per my experience, because I had started my career with DRI in only 1990 and almost worked for 3 decades. So as per my knowledge and understanding, this is the only process where number one, your cost of project is less. Number two, there is nothing is waste. You make DRI, and with the waste heat, you make power, and even char with the imported coal, which is very, very less, that is also used in making power. So what I feel, if we decide to give the best raw material, that is good quality of pellet and imported coal, this is the only process which gives you maximum profit. That's the main thing. And because we need more metallics, more DRI to meet the government target, to meet the 500 million ton target. So future is definitely there. But at the same time, as the government is speaking about the green steel, green power, so the role of syngas, which is suddenly getting momentum, plays very, very important role. But making syngas, making hydrogen is very, very costly. So everybody cannot afford. At the same time, if we see out of 120 million ton, this 85% production is by private sector. And in that 85%, almost 50% is from secondary producer. Now, secondary steel producer do not have that much of money where they can just think and put the syngas based DRI plant. So still I feel that this DRI technology is going to help in a big way, and government should take care that whatever power we are generating from waste heat, it should be approved as a renewable power, because we are not burning coal to make power, we are burning coal to make DRI, and whatever waste is there, we are making power. So I feel this is going to rule the market. Whatever people say, government say, it is not going to lose any demand in the market.
Thank you, sir. Sir, my next question will be the availability of quality scrap is a challenge in the current scenario. How much advantage we can get by using 100% DRI instead of scrap, since you are using 95% DRI in your plant and only 5% scrap. So this is a very good example which people can take of maximizing the use of DRI. So wanted your view on it, sir.
Yeah, you are right. Actually, getting quality scrap is a challenge until unless there is some big war in the world. Now the wars are not that except Ukraine and Russia. So definitely this is going to a challenge. And if we see the quality and quantity of the scrap which we need is going to provide a very good market to DRI industry, maybe coal gas or gas base. So what I will say that all the sponge iron manufacturers, they should target to feed best quality of raw material and maximize productivity by minimizing the downtime, minimizing the shutdown, minimizing the breakdown, maximizing the productivity, improving the quality of the product. Earlier, people used to make 78 FEM, 79 FEM. Time has gone. We have to target 84, 85 FEM, 90 to 93% metallization. And we should focus to maximize the performance of the plant and minimize the energy consumption. So once we will do, I think this is the most consistent raw material available on the earth. And with pellet route, it is much better. We have already done in our plant by maximizing the Fe total in pellet. We are making now 66 pellet. We are making 85 plus FEM DRI. And we are successfully using 95% sponge iron without buying any scrap from the market.
So my
Pratik,
last
you may
question,
also take audience questions.
Surely,
I
surely.
think the chat box is flooding with questions. So please take the relevant questions from there also.
fine. So now we will be taking some questions from the audience side. We have got
Sure.
many questions from
Sure.
them. Yeah. So one question is that heat time for single heat, or how many heat per day we can take?
You see, it's a very I'll say peculiar question, because it depends on the raw material which we are using. If you are using silica ramming mass and 79 FEM, then definitely your number of heat will be 6 to 7, and tap to tap time will be 4 to 3.5 hours. But if as we go on improving the quality of input raw material and use neutral ramming mass, then definitely your tap to tap time is going to be less. Your heating time will be less. So you can easily achieve more than 8 heat. 2.5 hour to 3 hour maximum is the heat cycle. So it all depends on the raw material which we are using. If it is better, definitely your fasting will be, your melting will be fast, your tapping will be fast, and your tap to tap time will be less.
Thank you, sir.
So one question that I see is relevant. A steel mint attendee is asking, we are producing low carbon steel and we have a high percentage of carbon in DRI. How to reduce carbon from it?
What is the percentage of carbon in DRI?
Sir, he just mentioned that we have a high percentage of carbon in DRI.
So we have to target why there is high percentage of carbon, because normally so far I have seen the challenge that people are fighting that their carbon sponge iron is less. They are not able to increase the carbon. and it is around 0.1, 0.0809 and 0.1, maximum 0.15. So it means there is something wrong with the operation. That's why your carbon pickup is there. So we can easily, number one, control carbon in sponge iron. Number two, even if carbon is there, if carbon is more in the sponge, definitely we have to see that we can reduce CPC, because you are adding CPC to reduce Fe from FeO. So we can easily reduce CPC because carbon is already there in the sponge iron. Number three, even if carbon is there, then definitely we have to put some low Fe sponge iron in the steel melting shop, so that whatever carbon is there, it should be compensated on account of low Fe sponge iron, just to dilute the carbon.
Okay.
Okay, sir. Sir, my next question from the audience side will be, which one is more energy efficient, IF route or EF route?
Again, it's a interesting question. You see, answer cannot be generalized, because nowadays people in electric arc furnace, what they are using, they are preheating their charge mix. And when I had been in Jindal, because I was there for almost 2 decades, they have achieved as low as 285 kilowatt hour unit per ton of hot metal. So it all depends on your technology, on your process, on your automation, on your system, how you can minimize this your energy consumption. If we use very traditional technology, then definitely your power consumption in your induction furnace will be high, because in electric arc furnace you feed hot metal, so there is no comparison. But now if we reduce that low quality of input in induction furnace by high quality of input, so we are competent with electric arc furnace, because we have to see in totality the cost of project of electric arc furnace compared to induction furnace. So this is all, you see, a cost benefit analysis which depends on so many parameters. There cannot be a generalized answer, because it all depends what type of process, what type of technology, what type of heat conservation system you have, right?
Right, sir. So one more thing is there that
Yes, please,
Indian
Pratik, go ahead.
Indian government is taking many initiatives for reducing the carbon emission. What are your views on it? What are the plans for the decarbonization?
Sir, too much is being discussed. Too much is happening recently. Government of India, under the leadership of Jyotiraj Sindhya ji, they made 13 committee, and lot of discussion is being taking place. For decarbonization, definitely, if we see, it needs very, very big calls, big decisions, big policies, where number one, government should give incentive to the people who are putting syngas based DRI plant. That's for the iron making. Then for decarbonization, the power which is coming for captive consumption had to be green power. So all this power had to made with the help of solar power, wind power or hydropower. Now, how far it is feasible to make power in daytime with solar, and then just giving it to grid, and then getting same power around the clock to the steel industry. So this is also very, very challenging. That's why government had kept the target of 2070, when other countries, they have kept the target of 2050. But yes, we have to very seriously work with the government. Otherwise, we may not be able to survive after maybe 20-30 years. So we have to see how fast we can work on this. And the first stage and the first weapon in decarbonization is the energy efficiency, which immediately we can do by improving the quality, by reducing the power consumption. And parallelly, we have to think how we can put plant with syngas based DRI process, and then directly that DRI or hot metal can be directly used in electric arc furnace. So we have to go parallelly, maintaining the balance. But yes, government is very serious. Let us see how far it is going to happen practically on the earth.
Sir, a Steelmint attendee wants to know what type of carbon generators should be used for 95% DRI Also, can you please share how to control phosphorus when using so much DRI?
Yeah, madam, you are asking this question or this is from audience?
This is from the audience.
Okay, you see, to control force in induction furnace, number one, there is no control of force in DRI. In sponge iron route, you cannot control force, you can only control sulfur. So whatever force is coming, it will be multiplied by all 1.3 and it will go to your DRI. To control force in your induction furnace, you have to have dephosphorylation, you have to have LRF. But fortunately, the iron ore which we have, it contains very low force. And in our DRI, the force is around 0.02425 finished force. So we do not need any LRF, we do not need any dephosphorylation in induction furnace. So similarly, people should target to use low force, whatever is available in the market. Because if thing is not available, they cannot do anything with the DRI. And if force is still high, then definitely they have to treat in induction furnace by putting ladle refining furnace. But we do not need any LRF, we do not do any treatment with the force. Our force finishes below 0.025.
Okay. Pratik, do you see any other relevant question from the audience?
Only one last question we can take and then we can sum up. Sir, my last question from the audience side is merit and demerit of using 100% DRI in induction furnace, and what will be the heat cycle time for 30 metric ton furnace?
So far, we have not used 100%. We have maximum gone to 95% in 30 ton also. And 4%, around 4% we have used scrap. So you can say 96% we have used. So heat to heat tap to tap time is about 2 hours 45 minutes max.
Okay. And sir, is there any demerits for using this much percentage of sponge iron? We have heard about the merit.
No, there is demerit only when the quality of DRI which you are using is not good. Because if you use very high percentage of DRI having low Fe, then definitely your cell slag generation will be very high. Your yield will be less, your productivity will be less. So if we are planning very high percentage of DRI, we have to ensure the quality of DRI should be very high. Because by using less Fe material, definitely your slag generation will be high. Your total, if your furnace is 30 ton, then your yield will be less. It will not be more than 82%. So your slag generation will be around 18 to 20. 5% more will go to slag. So with more percentage of DRI, you have to ensure the quality of DRI also. With same DRI quality, you cannot plan 95, 96%.
Right, sir. Yeah, Lalita, over to you for the closing remarks.
Yeah. Sir, one last question. One attendee wants you to comment on the future of gas-based DRI in India.
Yeah, it's a very good question, very interesting question. Future of DRI through gas base is very, very bright. But the only concern from where the gas will come. Where is the gas? Who is going to give the gas? So government, you can't depend on government, because there was a plant that is Vikram Ispat Limited in Rayagada, Maharashtra, which was put thinking that government will give the gas. There is a pipeline of ONGC, but government was not able to provide the required quantity of gas. As a result, they sold the plant to Welspun Max Steel. Then finally, Welspun sold the same plant to JSW. So there is no gas from government side. Now, to put gas-based plant, you have to put the gasifier. You have to put syngas formation. Here also there is a challenge from where coal is come, from where what quality of coal you will get. There is no commitment from the government. We have seen the case of JSP Alangul. The plant was ready, coal was not there. So future is bright, but with the future, we have to see the practical situation. There is no gas, there is no coal, and the cost of project is so high, people cannot afford to put that plant. Only big people, top 5 people can think to put syngas based DRI plant. like Tata, Jindals, or maybe some other company. But everyone cannot think they can plan to put gas-based DRI plant.
Okay, well, that was the last question we could accommodate for this session. Due to time constraints, we have to end this webinar here. We hope that you all enjoyed this session as much as we did. A big thank you to Mr. Vivek Agrawal for taking out time to be with us, and to the audience for attending this webinar. Last but not least, I thank our supporter, the Indian Steel Association. A lot more is there for you all in the upcoming sessions, so please keep watching. This is your host, Lalita, signing out along with my co-host, Pratik Srivastav. Thank you, sir. Thank you all.
Okay.
Thank you.